So we got our constraints all ready to go. So let's, we need to set up some properties on the actual geometry itself, right? So I'm just going to drop an IBD configure, connect that up. What this does, yeah, it allows you to set up, you know, simulation attributes beforehand, before the simulation actually starts, right? So initially what it will do is pack everything. So if I drop a null at the bottom, you'll see, you know, our geometry is all packed. Now you can tell that just by when you make selection, you can see the big pieces, and we don't see the wireframe anymore. But it does a lot more. So we can, if we come to the bottom here, this physical attributes, we can choose metal, and then maybe set this to steel, for example, and then you can have it to be dry or slippery, right? I'm going to leave it as it is with dry. I'm going to add the friction as well. I'm going to turn off the bounce. I don't want it to be bouncy at all. So that's good. So that will set up some attributes on our proxy geometry, because this is what's actually simulated, right? So if we come up here now, we can see we got bounce, density, friction, and the name there. Okay. What I also want is to you know, to hold the actual object up, because now it'll just fall over, but we want to pin these bottom parts to the ground. So if we come here to the bottom, you can see with the constraints, we can build these pin constraints at the bottom here. Okay, and what I'm going to do is do this use bound. So if we come up here, we can make a use a bounding box, and then set this to be 6 by 0.2 by 6. And you can see that I'm just kind of grabbing the bottom, and then we can even visualize that if we set this to pinned. And let's see, we should be able to, there we go. So you can see the parts which are red now, they have a value of 1 for the pin, so anything inside there is 1, and this means it won't move. So you can do this in two ways. So like in week 1 we use the active attributes, but I found you know, it doesn't work in exactly the same way. It in principle it does, it just stops these pieces from moving, but I found with the active attribute it kind of stiffens everything around it as well. It seems to stop the fractures from propagating through. So yeah, I want everything around it to be able to bend and flex, and for the glue constraints to break around these. So I you know, I found that the pins worked better in this case. I think that should be good. We can turn on the active attribute. I don't think we actually need it, but I'll leave it on anyway. And then yeah, I think everything else we can leave as it is. Let's drop our RBD bullets solver, connect that up, get rid of that null, don't need that. Okay, turn that on, and we can see we don't have any errors right away, which is good. And then we'll connect the collider into the collision geometry there. Let me just press Alt to tidy this up a bit, maybe put this in the middle. So for the solver, so let's see, what do we want to do? I don't think we need to do anything here. Leave them, you know, we've got these kind of set up already. For the collisions, we do need to change this to concave, and remember to be very careful about using that. I found here that it was fine because it saved me having to make convex geometry out of all this, and it worked okay for me. But you know, in your case, if it turns out that it's not really working, then you know, you might want to change this and make convex geometry. We need this to be deforming so that you know, we actually get that animation. We don't want to ground. Well, leave the gravity as it is. It's fine as it is. I'm going to push up the constraint iterations. I found for the plasticity to work, especially for the metal effect, you know, for it to be very stiff and fast, I found that I need a lot of I need to push up the constraint iterations, and I'm actually going to give myself just overall sub steps as well of 6. Okay, just found those, you know, after some experimentation that seemed to work okay for me. And now if you come into this constraints tab, a feature that I really like about this solver, this new node, is this breaking threshold. It sets up this for you, which is really handy. So if we, well, first of all, if we come into the soft constraints and make sure that we have plasticity turned on here. I'm not sure if it'll work anyway. Well, we'll turn that on anyway, just in case, to make sure it actually is, you know, it works. And come here to the breaking thresholds, right? And then so for the connectors, so only for the connectors, right? I only want them to break the things which hold each of these pieces together. I want them to be able to break whether they are stretched beyond 0.01 or the force is greater than 20,000. So these values you can actually see if I just go simulate one frame and then go into my geometry spreadsheet, and let's see if we change this to constraints geometry and then go to our primitives, and we can see there we've got, can find it, got a force there, okay, which will you know, if this value is higher than this value, then it will delete the these constraints, right? So that's good. Let's go back, and I'm going to go to cache this out. Let's drop an abd IO. Okay, so this will cache everything together. So for this abd IO, I'm going to be doing something a bit different. Okay, I'm going to be doing the geometry and the points. So from here we get simulation points. So that's just a excuse me, a point to represent each piece. I'm not going to cache the constraints or the proxy geometry because you definitely don't need it anymore, right? So for this to work, we need a rest geometry, right? So that's just this on one frame basically, right? So I'm going to save it into my geometry folder, call it rest.version1 .geo. Okay, so notice this, I'm not putting the frame number there because we only want the one frame, right? I'll call this metal rest version 1, and then for this one we'll save it in the geo as well. No, well, actually maybe we'll save this in sim, maybe this one also sim. Okay, save that, so that will create that file for me, which will just be the first frame. And then this, I'm going to change it to metal.version1. Let's make another folder, metal.version1 $f3.geo, and that should be good to go. Okay, check load from disk. I think we've got everything we need in here. Yeah, and then we can save that out. Just before I go, I noticed a silly mistake that I made earlier. I forgot, so there's no constraints coming out here. If we actually drop a null here, we can see there's nothing, no constraints, right? That's because this needs the proxy geometry to generate those constraints, right? So just connect those back up, and then we've got constraints going in there, and everything should work fine. And also, yeah, I'd like to actually bump this up to about 70,000 we've got there. Okay, just to be sure, let me just turn up that point visualization. Just sim a couple of frames, because yeah, without those constraints, it will just drop. There we go. So just a few frames there. We can see it's starting to work. The constraints breaking, and it's starting to buckle under the pressure there. Okay, so I'll save that out. I'm going to do the whole 100 frames. You might not need to necessarily do the whole 100 frames because, you know, the collider stops at 50. But I'm just going to save them out just in case something kind of gives way after that and falls, you know. So, yeah, yeah, I'll say I'm going to do the whole 100 frames, and make sure to, maybe we'll save this this in case it's different, you know, we've made changes above. So save, well, let's turn that off so we don't get the error. Save to disk the rest geometry, and save the whole simulation out as well.